Hey guys, let's take a look at a question that's takes this linear function stuff and raises it, to the next level. So let's make sure that we're, you know, figuring out how to figure this stuff out. So we'll jump in. So we have this little situation. It says there's a thermometer that was placed outside on a very cold day. Now you hear my southern accent, so you know that cold to me is not cold to a lot of people, but then so very cold day. You can see if you agree or disagree with me. The temperatures are in Fahrenheit, just so you know. Um, but it says, interestingly, the temperature changed at a constant rate on this very cold day for 8 hours. So constant rate of change for 8 hours, either increasing or decreasing. It doesn't say that in the sentences, the paragraph. So it says recheck the temp every hour for 7 hours, but she only logged the info on the table right. So table on the screen. If X represents the number of hours since the thermometer was placed outside, and Y represents the temperature at that time, then, and we're actually going to answer a different question. Let me back it up. Then when was the temperature? What was the temperature when the thermometer was placed outside? Okay. So we will worry about the question in just a minute. First things first, let's make sure that we're clear on what this is saying. So, you know, you're watching a video, you're sitting back, watching. Hopefully, you're writing some things down as you watch because that's like being a really engaged, active learner. But even if you're just watching, that's fine. But just know that I'm kind of walking you through the thought process of like how you would approach a similar problem. Like if you're reading something like this, like there's a lot of stuff going on here. If I was reading this for the first time, or in fact, when I was reading this for the first time, because this is based on a problem that a student asked me this week. It was my favorite question of the week. I had to read through it probably 2 times, just like read through. And then I went back and started looking at specific pieces of information. So that's that's what you would want to do most likely. Okay. So there's some key information. Constant rate. It changed at a constant rate. That's super important. Um, maybe 8 hours is important. Maybe not. It says Reese check the temperature every hour for 7 hours. That's kind of different. She only logged the info over here. So we've got an XY table, but we don't, it's not very self-explanatory, right? It doesn't tell us much information. So this paragraph is super important. This paragraph, I don't know what that star is supposed to be. It looks like a spider web more than anything. Here says if X represents the number of hours, X represents the number of hours. X is hours. Okay. Since the thermometer was placed outside. So the 2 here means 2 hours later. So it was put outside 2 hours later, something. And Y represents the temperature at that time. Okay, so Y is the temp or the degrees. I mean, it's, those are both ways to characterize that or to kind of label it. Okay, so after 2 hours, the temperature was 5 degrees. Yeah, for me, that's super cold. After 4 hours of that thermometer being outside, the temperature was 16 degrees. And after 7 hours, it was 32.5 degrees. Okay. So understand that as you're reasoning through these types of problems, like you're reading it several times and you're picturing like that situation. And if you can put yourself in that situation, try to, like think, like I just said, oh my goodness, 5 degrees. Like, I'm just like, I just can hardly imagine being, out in that cold. I have been out in that kind of temperature, but it's rare for me. And so depending on your experience, you might say, I've never been in 5-degree weather, or you might say 5 degrees is nothing. I've been in 20 below, whatever. So, but doing that helps your brain to understand it better. You're just getting a better picture of what this is talking about. Okay. So now we can think about the question. What was the temperature when the thermometer was placed outside? Okay. Well, I only know after 2 hours and 4 hours and 7 hours. So I don't even have like 2, 4, 6. Like there's not even a pattern to that. Um, there's not an obvious situation happening here. So what was the temperature? So think the temperature, temp, Y. That's a Y value. When the thermometer was placed outside, when is hours. That's an X value. So we are finding Y. That's what we're trying to figure out. We must be able to know what X is to figure out Y. So think about how many hours would X be equal to if it was the moment it was placed outside? Does it make sense that X is 0 in that case? So if X is 0, that means, because remember, X is the number of hours since the thermometer was placed outside. Well, if we just put it outside, then it hasn't been any hours. It's been 0 hours. So when X is 0 is what this is saying. Okay. So we need to know what this constant rate is. That's going to be really key. So we're going to use the slope formula. Remember, slope is represented by the letter M, and slope is, I'll bet you've seen this formula before. Subtractor y's, over subtractor x's, or the change in y over the change in x. Okay. Well, we have x and y here. We have an actual xy coordinate. In fact, we have 3 of them. Now you can actually pick any 2. You only need 2 of them. I would pick these 2 for sure. I wouldn't pick the 7 and 32.5 just because it's got a decimal in it. There's no reason to use a decimal if I don't have to. This is going to be much more straightforward. So if I'm subtracting y's, I'm going to do 16 minus 5 over subtract x's 4 minus 2. 16, 4, 5, 2. Okay. You want to make sure that if you start with 16, then you start with 4. All right. So 16 minus 5 is 11. 4 minus 2 is 2. So I could think of the slope as 11 over 2, like a rise over run situation. Or I could say 11 divided by 2 is 5.5. It doesn't really make a huge difference as far as that goes. Now from here, there's a couple of ways to start to think about what was the temperature when X was 0. Because right now we just figured out the slope. We figured out that the temperature is going up 11 every 2 hours. That's key. Let's understand what slope means. 11, this is the Y values, and the Y values are the temperature. So it's the change in the temperature, temp, over X, right? The change in X, the change in the hours. You see how all these little things that you've learned separately are just coming together in one piece right here. So it's kind of, I think it's kind of cool, but maybe it's just me. All right. So this is telling us every 2 hours, there's an 11-degree change. And because it's a positive, it's going up 11 degrees. And that makes sense, right? 5 plus 11 is 16. And that was 2 hours later. Okay. We don't see it as easily here, but just know that that same thing's happening. So think about how we can use that to figure out when it was at 0. We need to back up to 0, right? So we're going to back up 11, right? So 5 minus 11. Well, we know that those are different signs, so we would subtract, and the sign of the bigger number is negative, so -6. That means if it was 5 degrees at 2 hours, then 2 hours before that, it was 11 degrees lower than 5. So it went down to 0, and then it went down 6 more, which is at -6. So the temperature was -6 degrees when the thermometer was placed outside. It was 6 below. So cold. Okay. So there's that. Stick with me and we'll add to this one in just a moment. Hopefully there's a link somewhere close.